Now that I have ArcGIS set up, my folder connection set up, and the data downloaded, I'm going to go ahead and open the data now. So I'm going to go into my ArcMap. I'm going to go to my File drop down, go to Open, and inside of where I had downloaded it and unpacked it. So when you unpack it, it's going to look like this. And if I double click in there, I should see a GIS folder. And if I double click in there, all the way at the bottom, I should see a workspace. If I double click on that, I should see an MXD document. I'll go ahead and open that. Once it opens up, you may or may not see a bunch of lines over here in the map space. So down here at the bottom, there's several buttons. This first button, which is selected, is called the data view. The second one is the layout view. Use the layout view for when you want to export an image or print it. This allows you to refresh this view, and this allows you to pause the view. If you don't see anything here, that's okay, because the very first thing we actually need to do is expand out all of these things. And what I'm looking for is actually something like this right here, where it says manholes, and yours might not say manholes because what I did here was intentionally rename this layer to generate this error so that I could show you what to do in case you get something like this that happens. And the reason why this little red exclamation point happens is because it's lost its connection to where it's located at inside of the geodatabase. So if you have any layers in here that's doing this, you can actually remake that connection. So all I'm going to do is just click on it and then click on it again. And then you'll see set data source window open. And what I can do is go inside of this data connection that I made earlier into GIS, into GDB. And inside of this stormwater1.gdb, this is where all of this data that's in this data frame is located. So if something is broken, it's going to be located inside of here. So I intentionally renamed manholes to something else to generate this error, and I renamed it to sewer points. So before this was named manholes, I just changed it to sewer points to simulate an error. So here I'll select this and I'll click add just to make a note here. This was the only thing that I renamed, so everything else that's broken, it should match up with its names here. So I'll just click add. And as soon as I do that, it's able to find the data and it should display it over here in the data view. Over here in the table of contents, usually when you set up a new map document, the very first thing you want to do is set the spatial projection. And you can see here that I've set it to NAD 1983, State Plane, Kansas North. FIPS 1501, and it is in feet. The next thing that I do is I start adding in my layers. So I usually start with locating where my site is, or starting with my site boundaries. So I'm just going to turn off these other layers. And what these are groups that I've made. So inside of this group, there are layers inside the group. So if you want to make a group, you can just right click here and go to new group, and as soon as you make a group, you can right click on it again and go to properties, and you can give this group a name. So maybe I'll call it system definition. And then you can actually drag and drop these layers inside of this group. And it's convenient because you can turn off the whole thing without having to check each thing in, or you can turn the whole thing on. And how these layers work, think of them as kind of like layers of trace paper or layers of paper. So if you have all the layers on, you're only going to be able to see the thing that's on the top. You can't see the thing that's underneath. You can set transparencies, and some of these layers are kind of transparent. Like if I turn on this Manhattan boundary, you can see the line and you can see the stuff that occurs behind the line. So if I turn on land use, you can see it will delineate underneath, and that line, well, it's kind of hard to see, but that line is supposed to be on top. Let me maybe do soils. And now you can see it a little bit better. So if I drag and drop soils and I put it on top of my system definition, I may not be able to see my boundary, but I will because I set a transparency in my soils. So in my soils layer, if I right click on this and go to properties, and I go to my display, I set a transparency here to make that layer transparent, kind of like trace paper. So anyways, going back into my system definition, this was the first thing I did, was try to locate where the Manhattan boundaries are, city of Manhattan. And then I had to make a decision, so I had to clip my data, because you obviously don't want to do all this geoprocessing out here. So I'm just going to assume nobody's going to choose anything over here by the airport. It's going to be within the city of Manhattan here. So this is what I chose as kind of like my clipping boundary, because I'll need to clip all my data. The next thing that I'll need to do is, well, the next thing that I did was, once I determined my boundary, is I worked on my digital elevation model. So that's going to be this thing here. And it came in as tiles, so I had to reproject them both in the X, Y, Z direction, so you can see these elevations are in feet. And you can tell if something is reprojected or not by just simply right-clicking on it and going to the properties, and then going into the source, and you can see the cell size. And if I scroll down a little bit more, and also you can see the X, Y coordinate system is set to feet. The next thing I did was I ran some soil calculations here, so you can see that I tried to figure out, or not soil, slope calculations. So I went from 0 to 2, I just went every 2 feet until I got to 16, and I just went 16 on up. Hill shade, this just helps the map read a little bit better. If I turn off the slope, you'll see what I'm seeing, what I mean. So if I zoom into an area, it helps the digital elevation model pop out a little bit. Somewhere in the DEM, you'll see these little dashes here, and this has to do with the way that the raster was processed. This is an error on the analyst part, so for us it doesn't really matter. This doesn't really affect us. If it does end up affecting you in an area where you're doing an analysis, I just don't think it's really going to matter with what we're doing, since we're doing pipe, but you can just estimate around this boundary what that's supposed to be. It's called a data seam. It's between each raster tile. So ideally what you want to do when you're processing these is you work with the last files and make sure there's at least a 1 kilometer overlap between tiles. And it doesn't look like that happened here. So moving on. So that was our topography. The other one was our land use layer. So this is an aerial taken in 2019. Going back to our topography, this was collected between 2017 and 2018 in the winter time. They always do this in the winter time because that's when the leaves are off the trees. The next thing that I did was soils. So this came from the Web Soil Survey site. Downloaded that massive geo database, clipped it of course, and then just pulled out the hydrologic soil groups. So this is A, B, C through D. So if I right click on these layers, so some of these data layers are rasters, and what a raster is just a series of grid cells. So let's just go back to this one. And I'll turn off the hill shade and I'll show you what these grid cells look like. So if we zoom in really close, you may or may not be able to see it on this one. Over here where there's more color change. But if I zoom in really close, you can sort of see the raster cells. So these are just cells. These are 1 meter by 1 meter cells. And each of these cells inside, I can use this identify tool. I can click in this cell, has an elevation value. So that one is 1069.078003. And then the other type of data that we have in here is more vector-based data. So vectors are points, lines, and polygons. So if I right-click on this, it will have an attribute table. And in the attribute table, it will have all the data related to each of these little geometry pieces here. So if I click here on this one, it'll tell me this is Wymore Kennebec complex, and it has all of this data just like on Web Soil Survey. The other thing I did was I took the bare earth elevation model and I ran some hydrology tools on here to try to pull out the drainage lines. I kind of played around with different flow accumulation values to see how much surface runoff I could try to capture in this area. So depending upon where you decide to run your analysis, this might help give you an idea of which way water is moving on the surface. Keep in mind that this does not take under consideration any water that's flowing through a pipe. So this is just surface. Think of this as just surface runoff only. And then some other things I added in here were some hydraulic information. So I did find out comparing, so this data here, this pipeline data, sewer lines, and the manholes, they also represent inlets and other kind of junctions, is not current. So this data was given to me in 2009. So what I recommend is not using this data and instead using the stuff off of Riley County GIS. And I'll show you how to bring that in here soon. The other thing I added in here that you may or may not need is the location of gauges. And again, this is another file that's not current. So there's one gauge up here at the top, and I think there's another gauge somewhere out here. Maybe not. Yep, up down here, there's another gauge. But again, this file is probably not current, but the location should be. There may be more gauges located around here somewhere. So inside of your ARC toolbox, you may or may not have the CE550 thing appearing here. What I did was I created a custom toolbox just for this map. If you don't have it, you can add it in here. You can right click on this and choose Add Toolbox. And I'm inside of my geo database. I'm going to choose this up arrow to get out of it. Up arrow again to get out of there. And inside of my models, I have this toolbox. You can select on this and choose Open. It takes a few minutes, but it will eventually open and you'll see something that looks like this. And inside of there, if you expand it, there is a model. You can right click on it and choose Edit. And this model will show you everything that I did to generate these different layers in the table of contents. So think of this as kind of like a diagram that shows all the steps that I took to generate the data. So if you wanted to, you can include this in your report to show how the data was conditioned and processed. So like over here, this shows like how I had to reproject the raster both in the X, Y, Z direction. So I'm running the raster calculator to change the elevation from meters to feet. And then this little thing up here is a parameter that I added in to change the spatial, the XY coordinate system to feet. And over here, this shows how I was able to generate the surface runoff patterns. That's what all this stuff is here. And I tried 4 different times to get it to come out. This shows how the hillshade was made, the slope was made, and a bunch of other things. So if you're familiar with GIS, feel free to play around with this. I will let you know that this is mapped to my computer. So as soon as you map it to your own computer, it may end up breaking the model, but that's okay. It should still work. You just have to remake all the connections.